Hi guys, welcome back to my channel. In this video we're going to talk about the Kotlin compilation process, Kotlin variables and their types. Also we're going to talk about what a mutable versus immutable variable is. We're going to talk about functions, and to finish all of this up we're going to make an assignment, and I'm going to walk you through the solution of this assignment after that. Also, guys, if you enjoy my videos, please drop a like and subscribe, as that would really motivate me to make more videos like that, and this would really show me your support. Coming back from our previous lesson with this print statement, as you might have guessed, the computer does not understand what we have written here. The computer, or the CPU, which stands for Central Processing Unit, understands only zeros and ones, or binary as it's more commonly called. So how do we get from this to zeros and ones? Good question. And the answer to this question is something called a compiler. It's important to understand with the compilation process, as it's going to give you a clearer understanding of what's happening behind the scenes. And to be a good software engineer, you have to make sense of how low-level stuff works besides the high-level one. Now, we're not going to go over everything that's going on during the compilation process, as that's out of the scope of our course, but I'll give you a high-level overview as what's going on when we run our Kotlin code and how does our computer understand what to do with it. So here's a high-level sketch of what's going on under the hood. Don't be intimidated by this. You don't need to know anything about the compilation process in order to write code, but it helps to understand what's going on behind the scenes. So the first step in our compilation process is the source code. In our case, it's Kotlin code. Kotlin is considered to be a high-level language, understandable by humans, but our CPU cannot understand it. Therefore, it needs to go through several steps in order to arrive at the zeros and ones, or in other words, something called the machine code. If we look at the second step, we see a Java compiler here. Why Java, you might ask? Because languages like Kotlin, Scala, and a whole bunch of other languages run on the JVM, or the Java Virtual Machine. Hence, all of them use something called a Java compiler to compile a high-level language like Kotlin or Scala into something called the Java bytecode. The Java bytecode is saved with the .class extension. So what is a Java bytecode? Bytecode is an intermediary stage between our high-level language and machine code. They're basically instructions for our CPU, but are still somewhat readable by humans, but not yet completely ready to be executed on our hardware. You could say bytecode is a very low-level programming language, but nobody ever writes anything directly with bytecode. This process is instead done by something called a compiler. A compiler is a piece of software that performs the compilation process. It takes the high-level code and transforms it into bytecode. And here's what the bytecode looks like. Mainly, they're just line-by-line instructions that our CPU executes. By the way, this is not Java's bytecode. Specifically, I took this from Wikipedia. If you're really interested about how Java bytecode looks like, you need to open a .class file, and you'll find it inside. Next up, we have the Java interpreter. The Java interpreter primarily performs the same function as the compiler does. Mostly it converts our bytecode that's stored in the .class file into the machine code. So just as with Kotlin, we take a high-level language and transform it into a low-level one. Here we take Java bytecode and convert it into the machine code. All of this leads us to arrive at machine code. The machine code is the language that our computer's hardware understands. This zeros and ones language is called binary. If you're interested in how binary works, let me know in the comments and I'll make a video about it later. Right now we'll move on to our code. By the way, this is what I love Kotlin looks like in binary. Let's go ahead and write some code. First of all, let's create a new file. Right-click on the Kotlin directory, new file, and let's name this file myNameVariable.kt. In our newly created file, let's write fun main open and close round brackets followed by curly brackets.
Inside the curly brackets, let's write var name equals Nick. The first thing that I want to explain to you is that whenever we want to have our code executed, we need to write it inside a main function. We'll cover functions later on, but here I want you to understand that you need to have this sort of main function if you want to have your program do something. Main is a specially reserved keyword for functions that tells our compiler that this is an entry point of our program. So you see it in all our following examples that every time we create a new file, we'll declare the main function, which serves as the start of our program, and we'll build from there. Once again, don't worry about functions for now. Just remember that this code is mandatory for our program to be able to do something. Now let's look inside the body of our main function.
First part is the var keyword. This is a declaration that tells our compiler that we want to create a variable. The next part is the name of our variable. In our case, it's name. Next up, we have the equal sign. This is an operator that tells our compiler that we want to assign a value to our variable. After that, we have nick inside quotation marks. Nick is the value of our variable. The type of our variable nick is a string. When you declare a string variable in Kotlin, you have to put the value inside the double quotation marks.
So what we're doing here basically is we're asking our program, if you could say, please store the nick value in our name variable.
But variables can also hold all kinds of data besides strings. Variables can hold numbers, booleans, characters, arrays, and objects. But right now we're going to focus only on strings and integers. Okay, now that we have specified that we want to store our name in the name variable, let's go on and create our age variable as well. Let's declare var age equal operator, and I'll store my age in this variable. The type of this variable will be an integer type because 31 is an integer. Great. Now we have our name and age stored in the two separate variables. Let's now print this to the console, shall we? Let's type in println, open round brackets, double quotation marks. My name is plus our name variable plus open another quotation marks, and I am plus age plus open quotation marks years old exclamation marks. Let's go ahead and run this, and voila, we see my name is Nick and I'm 31 years old. Let's break down what we have written here. Here we're using something called string concatenation. Basically, we're telling our program to glue together all of this data into a single string. That's cool, but how are we able to insert an integer variable age into a string? Well, Kotlin does that for us. Basically, it's smart enough to sort of glue together all of our data and to automatically convert our age variable into a string. We can also improve upon this by using something called string interpolation. This allows us to insert variables directly into our code without having to use a plus operator and concatenate strings. So if we use a string interpolation, we can rewrite this as following. Println, open round brackets, open quotation marks. My name is $name, and I am $age years old exclamation marks, and we have to close it. If we run this, we see that the result is identical to our previous code, and it's much easier to read and write. So here we are sort of inserting directly in our variables into our string. And in order to do that, we have to use a $sign before variable name. Let's look into one of the most simplest but yet important features of Kotlin and other programming languages, and that is comments. Comments can be a single line like so, started with two slashes, and let's write this is a comment, or they can be multi-line. Let's type in slash star, and let's go into the next line. Let's type in this is a really, and then let's go on to the next line, really, really, and then long comment. Comments serve two purposes. First one is the obvious one. You comment your code to remind you about something, like why did you use a certain approach in this part of the code, or to explain your approach to someone who's seeing your code for the first time. The second purpose is to comment out the code that you're temporarily not using for some reason, but you don't want to delete it. Cool. Now that we have a basic understanding of what variables are, let's cover another concept. We'll talk about mutable versus immutable variables. Let's go ahead and create a new file in the same directory as our hello world file. Let's do that by right-clicking on our Kotlin directory, new, file. Let's name this file mutabledog.kt. Cool. So I want to show you what a mutable variable is. The name is pretty much self-explanatory, so let's take a look at it. Let's type the following: var dog equals Rocky. Switch over to the next line. Println dog name is $dog, and let's go ahead and switch to the next line. Dog equals Spike. Switch to the last line. Println dog name is now $dog. Now let's go ahead and run this. And what do we see? First we see dog name is Rocky, and second time around we see dog name is now Spike. What we did here is we reassigned a value to our variable, but we can only reassign variables that are vars or mutable. So when you see a var, you know that this variable can be changed. In Kotlin, we have two types of variables, mutable and immutable. When we want to declare a mutable variable, we start it with var. And when we want to declare an immutable variable, or in other words, a variable that cannot be changed once it was assigned a value, we declare it with the val keyword. Let's see immutable variables in action. I'll go ahead and write the following: val name equals John, and then we can try to give it a new value. On a new line, let's type in name equals Paul. As you can see here, the name part is underlined in red. And if we hover our pointer over the name variable, we see that the compiler tells us val cannot be reassigned. So what's the point of having immutable variables when we can just use mutable ones all the time? Well, immutable variables are actually preferred to mutable ones as they lead to less mistakes in the code. Let's see a problem that a var or a mutable variable can cause. A mutable variable can be changed at any point in the code. So if we return to our code, and let's change our code a little bit to help us imagine some production code. After the second line, let's go ahead and type in a multi-line comment. So start as usual with a backslash and a star, and let's type in imagine some long piece of code here. And the thing is that we might have 20 or 100 lines of code between these two lines. And at some point, we might forget or miss what values we assigned to our variables before. And this can cause unpredictable behavior. As a rule of thumb, always use val unless you're sure that your variables need to change later on.
Great. So in this lesson, we covered the compilation process. We also took a look at variables, the difference between mutable and immutable variables. We took a look at comments, what a string interpolation is. I hope you enjoyed this lesson, and I'll see you in the next one.